Hello, I'm Jack Rickard, and this is the A1323 TV show. This is my compadre and consigliere El Breno Noto.
Hey, good to be here.
Back in the day, we were EVTV,
I know.
but clearly A123 is
taking over
the entire show.
I know. Batteries, all kinds of fun stuff going on.
In the news this week, did you see?
I did hear.
Criminy. These companies, I cannot write this as a fiction script.
No, you can't make this kind of stuff up.
It would not be believable.
No, it
no
wouldn't.
one would buy into it.
No.
The willing suspension of disbelief does not extend.
That doesn't extend
to this.
Not to this market.
And their raging self-sense of infallibility just drives me to destruction. General Motors, in their Brazilian dollar battery test facility.
Right, up in Michigan? Or
Yeah,
okay.
Suffered an explosion this week.
I heard about that. The fellow's going to be okay, though.
Well, there were 5 people injured in what was characterized as an explosion. The fire department, expertly, of course, said it was an explosion of hydrogen sulfide gas because he knew that about batteries.
Oh, yeah, those batteries will have that, you know.
Yeah, well, lithium batteries don't, thank you. An explosion of gas, 5 people injured, 1 had to be hospitalized, and,
wow.
but they look for a full recovery. They were testing batteries. God love them.
Conflagrations, explosions. Oh my God, they're going to ruin us.
David Viu has gone from being the devil incarnate to my hero. That he has not already resigned. This man has got balls.
That's right. Jack's starting to feel sorry for him.
That he would be seen in public. Guess what battery they were testing?
I can't imagine.
A123, they had announced, was going to be used as the official team battery for the 2014 Summer Olympic General Motors Spark.
Oh, they were going to loan him to the Olympics?
No, I'm making all that.
Oh, okay.
The GM Spark was going to use the A123 battery. They were testing it. It blew up.
Holy, well, I guess they're not going to use that one. We don't have any of those here, do we?
Oh, yeah. Place is just
the place is ready to go
up with them, and they're sending more.
That's right. There's more on the way.
I just ordered a P28S module from Shenzhen, China.
Oh, you did? Mm-hmm. Okay.
Yeah.
Hope it doesn't come on fire.
At about $10 a cell, and they won't tell me if they're used or not or anything about them. But I got to see one.
Yeah, we've got to see what one looks like.
A123 has actually, they've had an 8th law firm pile on the class action law.
Oh, they got a dog pile on the class action.
And now they show up as the main component of the explosion.
Oh, my goodness.
Oddly, the batteries weren't damaged. Well, actually, they were. These batteries do not give off hydrogen sulfide gas, and the reason that you could have an explosion and have 5 people injured, but 4 of them not badly enough to go to the hospital, and 1 kind of overnight, is apparently the batteries vented and the gas exploded.
Oh, okay. Yeah, I was just curious about it. Yeah, an explosion of those batteries. Yeah.
What kind of gas is vents from a lithium iron phosphate cell?
Nothing that's too bad, right? What do we got? What's in there? Some ethanol?
It's basically some ethanol, some methanol, some ethylene glycol, like antifreeze, some carbonic acid, and
not a lot of it either.
Right,
yeah.
and so this is like a whiskey fire. You can pour ethanol in your hand and light it, and it burns with a blue flame, but your hand won't even get warm.
Yeah, right.
It's got quite an escape velocity. I guess if you atomized it and then exposed it to some ignition. But
maybe,
what I prefer is open the doors.
Yeah, that's right. Turn a fan on. Well, don't let the fan fart, though.
We've never actually seen the gas or the venting. And we've vented some, and we've had some fires, but we've never really seen the gas go.
Not like that, no.
But we're in drafty old buildings with barn doors literally.
Yeah, right. I guess it can't concentrate.
Fans going and stuff, and so the ventilation is a huge deal. Take note.
Well, the cigarette's going, I guess it just flames it off consistently, you know, it never lets it build up.
Bob Lutz was on the Colbert Report.
Okay, yeah, he's been making the rounds. Colbert Report, yes.
This guy is a hoot. But Bob Lutz showed up, did 40 push-ups. He's 80 years old.
Oh, really?
On stage.
Okay.
And proclaimed that the 2289 of March is just the beginning. It's going to be 3,000 units a month from here on out.
Really?
And
okay.
We'll see.
Yeah, we'll see,
I can't wait to see the April figures.
Yeah, that's right, exactly. Now we've had a prediction.
I think there was a bubble there for the HOV lane thing.
Yeah, for the Californians, yeah.
And so we'll see what happens in April. Anything could. I can tell you that people at Havelwaltz are very pleased with them.
Are they? Okay.
They like this car.
Okay.
I think it's an engineering marvel and horror
yeah,
at the same time.
That's right, simultaneously.
103 multiprocessors, 10 million lines of code. We went to the moon and back several times without that many.
Without 10 million lines of code.
10 million lines of code. So, who knows?
Yeah, we'll have to see. Wow.
But you know the slow sales of the Leaf and the GM have, and this is another thing I would predict and did. A lot of the OEMs are issuing a lot of press releases. Volkswagen has the EV of the week, of course.
Right.
It's never produced an electric anything, but they have the EV of the week.
They do. They've always got something coming.
They must have announced 35 different electric vehicles.
Yeah, I would like a VW electric vehicle. That'd be cool.
Too.
Yeah, that'd be cool.
I think they ought to do one.
German engineering.
They'd rather do press releases.
Press releases are a little cheaper.
Ford has actually designed the Ford Escort and delivered, 10 of them?
Yeah, less than a dozen.
Well, they're a pretty smart company. You know, they didn't really get bailed out.
No.
And they've been meeting customers' needs with their cars.
They have. Yeah.
Their advertising's very good right now. Their cars are very good right now, and Ford is kind of on a roll.
Yeah. Ford's actually doing well.
Here's their new announced strategy.
Okay.
They're going to put one in each showroom, and if you want one, you just fill out a form, and 5 or 6 weeks later they'll mail you one.
It'll show up. Oh man.
Yeah, they're going to build to suit.
Okay.
In other words, there is no big inventory overhanging, and never will be if Ford focuses. If you want one, let them know and put down a deposit, and you'll get one. And I think that's a pretty smart play.
I think that's probably the way to go.
But it's not going to
it's not going to do the big numbers. Sales. No, exactly. They're not going to do big numbers that way.
Do you recall the relationship with Think and Interdel and Interone?
Yes, absolutely, yes.
There is some angst over this right now.
I saw that. I did see something. I think you had emailed me something about
the company has been bought out of bankruptcy, Interone, Interdel, and Think.
Oh.
By a Russian who's a close personal friend with their president.
With Vladimir Putin?
Yes. They were making batteries using technology developed at the Argonne National Lab in Illinois. And they received hundreds of millions of dollars.
Yes, that's right. Of our money, that's right. Oh, man.
To produce all this, and now for 10 cents on the dollar, the Russians are taking it to Russia.
Oh, Jesus. Out to Siberia.
Wow. Well,
and hide it out.
Is that any crazier than me buying A123 cells from Livonia, Michigan, from China?
From China, yeah, I know it's not. It's all crazy. It's all nutty.
I did hear that they have 150 Thinks, or they have the parts for 150 Thinks.
Yeah, they're supposed to be still. There's 2 guys there building them, and they just sit there.
They're going to sell them now instead of for $39,000 for $22,500.
That would have been a better price in the beginning.
Well, sure, it would be. It's like a little smart car.
Yeah, a little Chinese smart car.
Not quite as good as it's like a Wego or something.
Yeah.
But at $22,500, you take off your $7,500. You're at
15 grand. That's not
bad.
bad.
Couple grand in California, you'd be down around $13,000.
See, now that's
that's a different price point, a different value proposition.
That works.
Even though it's a little car, it's primarily for in town. But at 12 or 13.
Yeah, right.
Yeah.
That's an expensive golf cart could run you that.
It's a different thing.
That's a different animal.
The George Hamstra net gain. I was told this week by someone close to me that we're 5.5 months.
Yes, that was moi.
Out from
when I went into panic mode the other
show. And we're working on a floor plan so all the vendors can see their possible spaces. George Hamstra was insistent to be signed up as #1 at the last one.
And he was, yeah.
He's sending us a motor.
Oh, really?
That's right, and a Warp 9. I think it doesn't have the rear shaft or something, but it's a Warp 9 with just the drive-in shaft. And brand new, all the latest gewgaws.
Okay.
And he's going to give that away at the dinner on Saturday night. You must be present to win.
Oh,
and,
okay.
So EVCON
that should be cool, yeah.
Be,
somebody can walk away with a motor, huh?
I would suggest to him that he have a way at his booth and just handle it at his booth where people would actually come and visit the booth and sign up
yeah.
for the drawing, and then we'll let him draw for a motor at the dinner.
Okay,
and,
nice.
And I think we could see some more of that.
Okay, cool. So we've got a giveaway prize then, good.
Keegan Hahn of Calb.
Calb, yeah.
Is going to exhibit and
That's what it sounded like, yeah, good.
The event. And so the things are kind of rolling. We said Rich Redmond has come. Have you got him on vendor row yet?
He's not yet, but Rich is coming.
Well, you keep working on it.
Yep, keep working on it. Yep.
He needs to be there. He's got too much new product.
He's got a bunch of stuff going on.
He's got lots of secret stuff.
Yep, lots of secret stuff.
We like that, and attendees do too.
Absolutely.
So we're 5.5 months out. Of course, the first break on price is the 1 June.
1st of June, yeah. So,
but we're starting to get some registrations, and I'm looking for a very good event.
We've got the space, and it's starting to develop velocity now. It's getting closer, yeah.
I'm getting kind of enthusiastic about a project you're working on. Is there any hope of it actually occurring?
Which project?
Where a J.B. Straubel delivers my Tesla Model S.
Actually, we are working on that.
I think that'd be great promotion for them and an outstanding thing.
And because I did leave a message, and
the timing's about right.
Yep.
I'm 2783 or 28.
Yeah, you're right around 2800. Yeah, and if they start, what do you say, 80 a day or something soon?
Yeah, they're going to do 1,000 signature series, and then they'll start with the 300 milers, and I'm going to have a 300 miler. So
yeah.
I think
you could be very, very close. Yeah.
I think the timing might be.
And I've also am contacting George Blankenship over there, who's their VP of Worldwide Sales and Customer Experience, just to get as many people maybe talking about it and see if we can get them to do it.
Well, one of the things they're accentuating is that they'll deliver your car anywhere.
Yeah.
How about to EVCON?
How about to the show? Yeah, exactly.
Is it anywhere but EVCON?
Yeah, that's right. That's the only place we can't go.
And if they could get J.B. Straubel to come do that, maybe give us a little presentation on the car.
Yeah, absolutely.
That would be very, very cool. So that's kind of what I've got for news this week.
Okay.
Let's take a look. We had a kind of an interesting development with the Escalade, didn't we?
Yeah, we've been actually working on that. Just so you all know, I am anticipating getting the motor in next week.
Okay.
So
they're anticipating. I'm kind of anticipating.
Good. Then everybody can wait with bated breath, and I think we'll be able to show some big movement on that.
Let's take a look at some of our final testing on it while it's on the bench.
Okay. Yeah.
We're going to have a little bit of fun with the Escalade before we put the motor in. We still have some additional testing to do.
Yep.
We tried our 120-degree magnets, and they were making a throttle position.
And we tested it against the on the tack signal. It seemed to work.
It seemed to be about right. It was kind of jumping around, but they always do.
They always did. Yep.
This is our General Motors throttle body, and this is actually how you control the amount of acceleration is, I suppose there's some injection going on.
Yeah, you got
the big thing is really this.
That's really
throttle body.
air. Yeah.
This is an air control into the intake manifold, and it consists of a motor and two potentiometers in there, and the ECU sends drive signals to this motor here, and that drives through some gears this shaft, which turns this plate, allowing air or not allowing air into the intake manifold. There are actually two 5-volt pots, about 3K. They're not really very big.
Yeah, right.
Potentiometers. And the ECU provides 5 volts and ground to the device. One pot varies from nominally 5 volts down to 0.
Yeah,
and the other one varies from 0 up to 5 volts.
Yeah, right.
And the ECU needs both of these. It uses one against the other as kind of a sanity check that it has good wiring.
And they're going in different directions, yeah.
Brain, you scored today.
Well, our local Cadillac dealer, which usually doesn't have anything that we need,
Right.
Actually had the plug sitting back in the parts bin at the store. It took them about 10 minutes. 2 guys worked on it, and they found it and couldn't believe it when they had one. I couldn't either.
Well, you know, I kind of can't either, and I sent him for one, but I was just hoping to get lucky.
Hoping we'd get one.
We did.
We
Even
did.
a blind hog gets an acorn now and again.
Yep, we got it.
Here's the issue. The Soliton ones, and we're using 2 of them simultaneously, have to be calibrated. I really wish they would let me just enter a voltage.
Oh yeah, just put the voltage in. We have to put it on and then
As
go
an
top
option.
and bottom.
You have to disable the Soliton, and then you have to go to your 2 throttle positions and press a calibrate button for upper and lower calibration.
Yeah, and characterize this thing, yeah.
Now, there's a couple of problems wrong with that, but it's particularly wrong with a dual motor. And we actually had an incident a year ago where somebody blew up their 2 motors.
Oh.
They got on one Soliton and disabled it, and they were checking calibrating the throttle, but the other one was on.
The other one was ready to go. Oh,
When
man.
they went to full throttle, and don't ever do this with an unloaded motor, certainly.
Yeah.
It went to full throttle and destroyed both
Immediately.
motors,
Oh,
and
man.
it could have hurt somebody.
Yeah.
Sometimes when those things go off at high RPMs,
Yeah.
they start throwing chunks of armature
Yeah.
out through that metal case.
Yeah, it could have grenaded.
Yeah.
Yeah.
It turns into a claymore mine. And so that's not a good thing. You'll have a tough time cleaning up after something like that, and your wife will have a lot of questions.
That's right. What
And
happened?
you don't really have a good answer.
You don't have an answer. That's right.
I didn't want to do this on the car.
No. It's better we do it off the vehicle.
Well, at least practice it once.
Right.
We're going to do it on the car. But fortunately, we have our throttle body, and Brian scored me a little connector, so I don't have to get in with little clips and tape and stuff trying to do this 6-pin
pins.
recessed plug.
Yeah.
And it's pins sticking out, little blades, and I inevitably short them. And
There goes that story.
so it's much easier with a plug and a little pigtail, and he got me one. So we've hooked that up to 5 volts and to our return for the 5 volts. We'll call that ground. And I've hooked that ground up to the Soliton signal ground. Now, why is that important? So we don't have 2 floating voltages. They're tied together now.
Okay.
The Soliton normally provides the 5-volt reference. I'm doing this with
That's
a power
right.
supply.
We're doing power supply, yeah.
And so either one is fine, but they need to be in common for the signal to be valid into the Soliton. And so we've got this hooked up. Why did I use the power supply? Well, the first thing we want to do is figure out which pot to use. One of them goes from 5 volts to 0. The other goes from 0 to 5.
Right.
I think I can actually calibrate the Soliton either way.
Either way.
I don't think it cares.
Okay.
But if we get it backwards, it'll be hard to learn to drive the car. You'll have to hold your pedal all the way down
that's right.
at the stoplight. And then when you take off, you have to release the pedal.
You can get full throttle with no effort, huh?
Right, and that's not how we're accustomed to
It's a little different.
And if you get it swapped around, it could be catastrophic.
Yeah, yeah.
And so we have to get the right pot and check what the output voltages are, just for my curiosity and edification. So we've wired this up with the 5 volts goes in. There's 6 pins. They're labeled A through F. A and B are actually the motor control drive signals that drive the little motor.
Going to come from the ECU, yeah.
Right. C is our ground. D is one of our throttle position signals. E is the 5 volts, and F is the other throttle position signal. So the first thing we're going to do is let's take one of our throttle position signals.
Here's I think one here, maybe.
All right.
Try that one. Is that a throttle
This
position?
is F. And right now, my meter's gone to sleep. I'm reading 3.38 volts with the throttle entirely at rest. Now with it, I go to 4 volts with it fully closed, but at rest it's 3.386. Let's make a note of that.
Okay.
Could you write that down?
Yep, and that's
F
at rest.
is 3.386, 3.385.
Got it.
Now brain here is going to set the throttle to as wide open as it will go.
Okay. And we're doing that now.
And that drops the voltage to 0.552. So F is actually the one that would be reversed.
Be reversed. That's not the one we want, yeah.
Let's go to D. And at rest, I'm reading 1.634 volts.
Okay, 1.634, and we'll open it up.
Now let me see it with it hard closed. That's 0.931 hard closed.
Right.
At rest, it's 1.632. And let's go to wide open. And that is 4.451. And so D is the one.
D's the ones we want, yeah.
That we want to use.
Yeah.
It varies from 1.6 to what, 4.4?
4.4, yeah.
And that's perfect. Your 0 to 5 volt pot is almost never 0 or ever 5.
That's right.
In fact, a lot of the AC controllers have a low and an upper voltage that indicate that you have a bad signal. It's a disable.
It's a disable, yeah.
If it falls below the minimum or above the maximum. The pulse width modulated DC are usually not quite that sophisticated, and I don't know that it really adds much.
Okay.
But in the case of the Soliton, we have to learn to do this.
Right, right. Yep.
And so we're going to take our turn off the well, I'm gonna turn this on the Solitons and leave it disconnected for the moment. We have no throttle input at all.
No, we don't. And
let's go over here.
Yep.
On my laptop, I've got a little Ethernet cable into the jack on the Soliton. And I'm going to call up, if I can, my Firefox. Make sure I have a fresh controller interface screen. And I'm actually going to go down here at the bottom of their configuration screen in the bottom right-hand corner is a function to disable the controller. And I'm going to click on that, and I get a new screen that says value set back. I'm going to go back. And now at the bottom, I have calibrate min throttle and calibrate max throttle. Let's not do that for the moment. I'm going to go over to our other Soliton, which is also on.
We don't want to forget that one.
And I'm going to go up and get me, make sure I have a fresh controller interface screen. And would you believe on the bottom of that one, I'm not getting. There it is, disable controller. And I'm going to disable the controller there. And it says value set and back. Let's go back. I get a new screen. And now I have calibrate min throttle and calibrate max throttle. Now, both controllers are disabled. I should not be able to run the motors.
Right, right.
You got to help me if we can.
That's right. Then we're in trouble.
And this is pretty easy. We're at minimum on the throttle body, so I'm going to say calibrate min throttle, and that's good. And I'm back. And now I want you to hold that plate full open. This is actually the throttle body we're going to be using. Oops, hold it. We have a problem.
It's not connected.
Yeah, we're not connected yet. Let's take our throttle now, signal, and let's connect that to D. Where's my wire strippers?
We got a little ahead of ourselves.
Yep. We have not.
Well, that's okay. There's always time for safety.
But there's never time for rehearsal.
We just go right in.
We have learned to shoot video on the fly. We don't like to rehearse anything. All right, now we're tied together there.
Now we can do it. There we go.
And let me see if I've got a voltage. I do. 1.587. And it's the same there. And it's getting...
no. You got to be... There you go. That's
at
1.587. Yeah, that's throttle.
All right. That's the throttle. Okay, let's go back and calibrate min throttle again. Value set. Let's go back to that screen. And now, Brian, if you will put the throttle to full position and hold it there.
Just make sure nothing's happening anywhere.
Tell me when you're ready.
Okay, I'm ready.
And am I reading a throttle?
4.362.
4.362.
4.365. Yeah.
All right, I'm going to hit calibrate max throttle. And back. Now I'm calibrated. I don't think I have to save anything or do any of that. We're set now. We have recorded the throttle min and max position into our right-hand Soliton. Let's go back to the left one, which should also be disabled. And let me make sure I've got a new screen on my browser, and I do. And guess what? We're disabled and have our calibration thing. So with the throttle off, I'm going to say calibrate a min throttle. It says value set and back. I'm going to click on back. And now, if you will position our throttle to its maximum, throttle body to its maximum position.
We're at max.
I'm going to hit calibrate max throttle and value set and back. And now, I believe there isn't really a thing to re-enable. I think we have to take everything down and bring it back up.
Bring it back up. Okay.
And so we will turn off our solitons. turn them back on. No, I don't want to read my email. I want the, and it's odd, they use 169.254.0.1 as the address of the Soliton controllers.
Oh.
That's actually the mesh address for mesh networks.
For mesh networks, yeah.
And I've used those with little wireless, hubs to make a neighborhood mesh network. And now they're calling that the self-assigned IP.
Oh, self-assigned IP, yeah.
And it's a reserved IP for self-assigned devices.
Okay.
And so I guess Martin decided to use that for this. But it's quite proper usage of it. And unfortunately, it's one I'm familiar with and
you can remember it, that's right.
I've typed it in 12,000 times. Right. Not with the Solitons, with the wireless networks. And so, here I am. And yes, we get our disabled controller back. And so we know we're enabled. And let's go over to this one and see what it says. And let me get that screen back. And I see my disabled controller back at the bottom. And the throttle calibration pane has disappeared.
It's gone, yeah.
So we're reset.
Okay.
We have it. And so, with this hooked up, I should be able...
Do we have to push our start button? Or
we already did.
We got errors.
We have errors?
Yeah, we have an error right here, don't we? Is that error light's on?
I don't know. Let's see here. Oh, we never did push start.
I don't think we pushed the start button. That's what I was confirming there.
Okay. You're probably quite correct. We have the Soliton set up where you have to have a start signal.
There we go. Okay.
And there we have it.
Okay, we got our start signal.
And now, I can control the motor.
Yep. Yeah, there you go.
With our throttle body.
Nice.
Nothing's running away.
No, it seems to be responding to the command precisely.
Now we've exceeded the RPM. We're idle.
We're at idle, yep.
And so you have to have a little throttle to exceed the idle.
We call that success.
Without much rehearsal.
And only a little flailing around.
And only a little flailing around.
Yeah.
Now, what's left to do? We bolt this somewhere in the engine compartment and hook it up to the...
just put the wiring harness back in.
To the regular wiring harness. We don't have to use this. We have to pick out pin D from the harness.
Yeah, right.
And we have to put a little splice in there.
Right.
And run that to the two Solitons.
Yes.
Which will already be on our 12-volt ground, which the ECU is.
Right.
And so that shouldn't be too much of an issue. We may run a signal ground to the ground pin as well.
Okay. Splice into the ground, just to be safe.
For giggles.
Yeah.
And then we have to hope that this does not load to that signal to the point where the ECU detects a fault.
A fault, yeah, yeah.
And so we got to hope the input impedance of the two Solitons is such
it doesn't mess up our
that it doesn't mess up our signal. Otherwise, we have to figure out a way to load the other wire.
The other one, the other wire, yeah.
Which we could probably do with some sort of a pot if we had to.
And just set it and then leave it.
Set it and forget it.
Set it and forget it.
Ron Popeil.
That's right.
Yeah, it'd be a one-time adjustment.
Yeah.
But that's the remaining issue on our throttle. Now, what does this give us? Well, this throttle position is set by the engine control unit. It sets that in response to a lot of things. Obviously, the accelerator signal. So we don't have to tap into the accelerator, but that's not really the problem. The problem is we also have, and this is what you get into on these higher end vehicles, is the advanced systems and environmentals, but we have our cruise control.
Yes.
And with this, our cruise control will still work.
And this is probably going to be sending some signal to our transmission.
Well,
maybe position as well.
No, it sends throttle position signal to the ECU.
That's to the ECU, and that may send it to the transmission.
The ECU sends it to the transmission.
Yeah.
Or notes it in doing the shifting. So this is actually the way I want to try to control these motors and through the solitons. As I say, my only concern is that this is using two signals that are not exactly inverse.
No.
They're almost scaled a little different.
Right,
I think they may
be
different size pots.
Yeah, they might be. Yeah, because they are different. They are different signals.
For example, you went from 3.40 to 0.560
right.
on F.
On F.
This is not the reverse of that. We're at 1.64 and 4.48.
Yeah, that's not exactly the reverse.
And this is a common thing. Most of the accelerators work exactly the same way.
Right.
They have two different sensors that are on a different scale. And the scale, you can put in the software and compare the two signals at any time, and one should be a function of the other, but not equal to it. If you have the function in the software, then you really have a good check where you can't get a false reading because one of them is shorted to the frame, or the two of them are shorted together, or one of them is open. That means you don't have a
throttle,
signal.
right? Yeah.
And that might save your life.
Right, exactly. Keep that thing from running away.
So it's not, and while it complicates things modestly for us, it's not a thing. Here's the problem. If our solitons, and we have two of them, load our
signal,
yeah, then we may have a problem there.
Yeah.
We could probably load the other one equally with a pot. I'd be more likely to use an operational amplifier or unity gain because it is infinite input impedance.
Okay.
And it's an amplifier that the input is virtually an open for all practical purposes.
Okay.
And but that follows, you simply wire the output back to the other input as a follower, and it has unity gain, and that will buffer
it.
The signal. We may want to do that anyway.
And do it anyway, buffer it.
These things have gotten to be pennies, actually. They cost nothing.
Really? And yeah, it might be a good idea to put one
Well,
in.
you have to put power to it. I have to put it on a little circuit board and have 12 volts to it and ground. And so it's a little additional complication, but it may be the ideal thing to buffer that signal from the throttle pod assembly so that the ECU doesn't get confused.
Right. Okay. Good.
And if we have any kind of problem, that's the first place I'm going on the acceleration. Meanwhile, this thing runs up my motor just fine.
Yeah, it's working great.
And so Seb was actually wanting me to somehow mechanically hook this in to that, and
we played with it for a little bit. And
I'm not very good with little mechanical linkages, and they break usually at 1:30 in the morning in the parking lot of a bar.
Right, that's it. Well, while the cops are standing there watching you.
Yeah, right.
What do you got there, son?
Or the four dudes.
Yeah, right. Yeah.
And so I really, if I can do it by tapping a line here, that's how we're going to do it.
Yeah, that's the way to do it.
And so that's another little test. We're doing some final little tests. This is going to be quite a bit of work to break down,
Yeah, once we break it down, it's got to go in.
And
We got to live with it.
well, no, you've got some work to do on
I've got to hog out
the end bell.
I got to hog out that end plate. Yeah.
and some little things like that. But we're about to start tearing this down. I'd kind of been waiting on a software upgrade from
Yeah, you were
Adnetics.
waiting for a software
And
upgrade.
it turns out they've piled a bunch of other stuff. They had it was an error in the last release, 1.51.
Oh.
The start signal does not cause it to run up to idle.
Oh, yeah, which it should. Yeah, you have to bump the throttle, you have to blip it to get it to idle, yeah.
Sebastian Bourgeois actually told me, well, of course it does. And then the next email message was, I went out on my 911 and you know it doesn't do
It
that.
doesn't do it now, since I upgraded my own software.
So we'll have that in a day or two, and that's been nearly a month. But I think they're kind of having a grand release.
Oh, okay. Of a whole bunch of upgrades to that software, yeah.
Yeah. They are trying to develop an AC controller, and it's taking some resource.
I bet it is.
And he came up with a cunning solution, and that was for me to give him some money.
Oh, there you go.
And I explained to him I didn't really want to be invested in one of our advertisers.
No,
potentially.
that gives them a little
But
bit.
we've
gives them a special place.
bought 10 Soliton controllers,
We
2
did.
juniors and 3
And,
Soliton ones.
we've got 8 Soliton ones and 2 juniors, yes.
And we're going to make those available on the website.
Yes.
In our online store that we're kind of getting
Who
into.
would have thunk it?
Started with some braided straps.
I know.
But I do like these controllers.
Yeah, they're nice.
So we got the latest ones with the good IGBTs in them.
We do.
He still wants wants me to swap these off, but these are fine.
These are fine,
I
yeah.
think, for what we're doing. And so that's what's going on there. But I guess we're a Soliton dealer now.
Yes, I suppose we are. Yes. Check the website occasionally. We'll get them up there.
Yeah, I don't know that we've got it up yet. But this is some of the flexibility we've got. One of the features, which I'm amazed that everybody hadn't jumped on, but this is still the only controller that you can idle
But
this
you can
way.
idle, yeah. It's a big deal.
It
For a
is
street
for
car,
automatic
yeah,
transmission.
for a street car with an automatic,
applications.
it's a big deal.
And we're going to be full automatic with the full torque converter and the whole full metal jacket Cadillac Escalade EXT. And I'm feeling better about it. Now we've got our throttle body actually running, our motor. I think that's a big step on the way. Stay with
I
us.
think so.
Okay, and now a little bit of an infomercial. We have a device I really like. I've kind of fallen in love with the J1772 charging standard, and for some very surprising reasons, I think it's kind of overdone. With the safety, I felt pretty safe before, and I still do now. However, we used a little NEMA 5-15 ordinary 3-prong plug to charge our cars, and that let us use ordinary extension cords from any outlets. The problem was they're not very strongly built. They're not built to be inserted every evening and extracted every morning. And after a few months, they simply start to break down from both the weather, but more importantly, the constant flexing of plugging them in and unplugging them. The J1772 standard has given us a very stout plug and a very stout connector on the car. An interesting guy has kind of enabled us in the DIY community. David Kurzel of Modular EV Power in Florida has developed some devices, both to build J1772 EVSE stations, but more importantly, I think, to be an easy add-on to your car to add J1772 capability. Our last 3 builds, the Cobra, the Swallow, and the Escalade, have used his billet aluminum J1772 charge port or inlet that you mount in the car. He sells his devices on eBay, but the inlets have become available from China, where you can get them quite inexpensively, and many of you are very thrifty people. And so he's discontinued the aluminum billet version that I like so well. And so I asked him to make me up 10 of them because I like them. They're more expensive, but they're also more solid. We're going to charge $195 for them if you want to share my wealth. And the package consists of the billet aluminum inlet port, the AVC2 board, and the manual. Let's start with the device itself. He's not really selling these on eBay right now. That's how this got started. I like them because he makes them. He's actually a hobby machinist. He's done radial engines in miniature. And this is a 6061 billet aluminum inlet. This thing will last forever. And it has a collar around it that has 6 holes that are drilled and tapped already for a number 6 32 thread screw, and that makes it very easy to mount this very securely in the car, which is important because, again, there's some weight involved in that plug and cable, and so you want to have it securely involved. This is a piece of jewelry. I mean, this thing is just gorgeous, but I can't tell you how many times in showing our electric cars that people have wanted to see what the charge port looks like. What do you plug it into? And this really dresses it up with the aluminum. And additionally, I mean, it's not going to fade and become brittle like the plastic and the inexpensive ones. It's made of billet aluminum. It'll last forever. The board he had works fine, and in fact, it's got some features that I think are actually just prime for the do-it-yourself community, but it was a little bare circuit board and a little bit fragile. So we had to put it in a little plastic box with a gland nut for the wires and so forth, which was time-consuming and kind of clumsy. He's upgraded this to the AVC2, and this comes in a plastic case with little ears on it with mounting holes, but you still have the same very easy to use terminal strip, very clearly labeled. This provides you with the ability to, it has a relay that energizes when it finishes the process of doing the handshake with the EVSE and has a connection and is receiving power. This can be very useful. It runs on 12-volt power, and you do have to have unswitched 12-volt to it all the time in order to be able to charge. We simply jumper the 12 to the common of the relay and take a wire out of the normally open of the relay, which closes when you have power applied through the connector. And that we route to our controllers as a disable signal to disable our car so I can't get in, turn the key, and drive away when it's plugged into the EVSE, which would cause quite a mess because the cables and the plugs are big enough that it would take some force to rip them out, which I would do. The one criticism I had of his program, he has delightful pigtail done, heavy wires for the 2 phases and the neutral, but he also brings out a green neutral wire, a blue wire for the co-pilot, and a violet wire for the proximity. The problem was I could never remember if it was the blue, the co-pilot, or the proximity, and then vice versa with the purple. So I would, in every case I've wired one, I wired it backwards and had to go back and swap them. I did a little brochure, a little instruction document with a diagram of this, and would you believe we printed out 5 or 6 copies, and I was reviewing them, and I had swapped the wires and had the wrong color. So there's a little 50-50 shot in here that you're just going to get wrong. So, but I do have that corrected in the manual now, and you get a little document that has some very clear diagrams on how to hook all this up in various ways to your advantage. So it's $195. I think it's very dressy. It'll last forever. It is a little more expensive than what he's selling on eBay, but you can get them here at EVTV, and we'll carry them until they're gone. He's made me up 10 of them. I think we have 3 with 7 coming in next week. So I think they really dress up your car and provide a much more durable interface for something you do twice a day.
Well, that was cool. I kind of like that idea.
Well, I like that idea
that
too.
was great.
The key was your ability to procure me that connector.
Well, all I had to do was walk in a couple places. I was surprised anybody had it.
Well, apparently they were too.
They were too. It was like they looked at each other and said, "We've got one," and it was like, "Well, wait a minute, we have to go back and get it because that may be wrong in inventory." And
we can do a book on each car and put that part number in the book.
It's in there, yeah. It's in the book.
If they claim they don't have it, we'll
tell them, "Hey, you got it. You got one somewhere."
And so we actually have controllers. I'm still kind of awaiting a software upgrade.
Yeah, we need that upgrade.
But there's some delay there. I think they've. I'm hoping that means some new features and
all kinds of fun stuff. I hope, yeah.
All kinds of candy and gewgaws in the latest
Yep.
Soliton software. We had discovered that their start button did not put it into idle.
It's idle, yeah. It started, but it wouldn't idle, yeah.
Seb actually told me himself on my email, oh no, it does that. About 20 minutes later, I get another email. Well, I went out to my 911 and guess what?
Didn't work.
It doesn't really do that anymore.
It doesn't do that anymore. I don't know how the hell we did that, but we did.
That's exactly what he said. And then he said, oh, we'll have a software fix in a day or two. And then it was kind of, well, we're working on some other stuff there. Could we combine it with a release in a week or two? Well, it's been a month.
It's been a month, yeah.
I need the software, so we're waiting. We're all
we're ready to go.
Over what the new stuff is.
I know we want to see it.
Someday maybe they'll write a manual for it. Maybe someday maybe I will.
Maybe you write a manual for it.
Yeah, the basics are in there. They have pretty clear documentation, but they have these inputs and outputs that can be used for a variety of things. But they don't really describe those in the book.
Yeah, right.
And so the add-on, which is a lot of the value of the product, is these
additional things it can do.
It'll drive a gas gauge, and you can use there's just all kinds of things you can tie into that thing. Obviously, we'll tie our
J1772 into interlock it.
To interlock it, but that's kind of obvious. But so the new software would be more features.
Cool.
And again, they already have a booth reserved at EVCon 2012. And so I'm pretty excited about that. But yeah, I'm getting a little heat that we're moving a little slow on actually muscling that motor into position.
We'll put it in this week.
Good.
Yeah.
Good.
Yeah, I actually started taking a little bit of it apart today. There were some modifications. The actual transmission's off of it now, and it's getting close. I can't stall any longer. I've tried as hard as I could, so we're ready to go.
Some of our senior board members. Steve Connolly sends me $10.
That's right. That's right. He's on the advisory board.
He's on the advisory.
He's our chief financial officer.
Well, right.
and our favorite, donator.
He's wants some bottom balancing.
Oh, okay.
Let's go show you some bottom.
There you go.
All right. Today we're going to cover a couple of things. Largely, my little cell bottom balancer here, at the request of Steve Connolly. I think Steve is in Tempe, Arizona. He was the first to arrive at our electric vehicle conversion convention, but I kind of work for Steve. Steve gives me a little $10 donation each and every week we do the show, and has for 2 consecutive years. It's really quite strange. He wanted me to describe this a little bit more. I'm going to do a very little bit more, And then, Steve, we're going to talk about something that it will become clear that this is kind of a dead end. This is something I cobbled together from some components laying around on the bench and this meter. It's a little JLD 5740 that measures voltage. It's a digital voltmeter. But it has two relays that you can set to do things based on voltage. And so I used that to make a little device that I could hook up to a cell, and it would bleed off current until it reached a certain voltage and then stop. And why would I want to do that? Well, that gets us into bottom balancing. And because we get kind of waves of new viewers as we go along, I'm going to have to review a little bit about balancing your batteries, why that's necessary, and about the two camps that's broken into, top balancing and bottom balancing. To do this, for some of our regular viewers, this may be a little repetitious. I'm sorry. It's an important concept, and we're going to have to take a look at it. And it's somewhat controversial. We have come up with something, although DeWalt actually has it patented, the bottom balancing circuitry for their power tools, which use lithium iron phosphate cells from A123. But most of the BMS guys do top balancing, and we'll talk about what that's about. When we make a pack in series as opposed to parallel, and that's what we do in an electric car, is put each of our batteries in series, we have a little bit of a problem. No matter who you buy them from or who manufactures them, each cell is going to vary in its capacity to hold energy slightly. This is not huge. With some of the cheaper cells, it can be pretty substantial. Over time, we've noticed that the manufacturing has tended toward a little better consistency, and we're getting cells that are a little more closely matched. But no two cells will hold the same amount of energy. And that's because they have different capacities. It's impossible to get a uniform flow of cathode and anode material onto the foils in exactly the same thickness when you're dealing with thicknesses that are in microns in some cases, quite thin. And so the capacity of the cells will vary. I'm going to put up here on the screen a image of a charge-discharge curve for a typical lithium iron phosphate cell. They all have essentially the same curve. The middle section will be flatter or a little more tilted, depending on the manufacturer and the chemistry, whether it's a lithium cobalt cell or a lithium manganese cell or lithium iron phosphate cell or one of the newer hybrid nickel cobalt manganese cathode cells. It's all pretty much the same thing, except some of them are a little flatter in the middle. This is depicting the voltage of the cell. And dead in the middle, where it's nice and flat, would be a cell that's 50% charged, or conversely 50% discharged. A lot of people use the analogy of the glass being half full or the glass being half empty to define whether you're a pessimist or an optimist. For an engineer, the glass is not the right size. It's probably in not the right position. And why are we using water? There are so many other liquids that could go into it. And so that's the joke for the day. Conventionally, the left side of the graph, as you see it goes up, that is the charge side of the curve as you'll normally see it depicted. And to the right, where it descends sharply, that would be the discharge side of the curve. Now, if we're at the middle point and we start our charge, we can pump in our maximum current, whatever your charger can do, 15 amps or 20 amps or 25 amps, depending on how many ducats you spend on your charger, and what size your pack is in voltage. And we'll start to increase the voltage of the pack very slowly. It takes quite a bit of energy to get it to go up even a tenth of a volt. And that's because we're on the very flat part of the charge-discharge curve. As we get closer to fully charged, that starts to turn up. And it'll start to turn up a little bit, I would say at 3.4 or 3.45 volts for the lithium iron phosphate cells that we are using or familiar with. The A123s, the China Aviation Lithium Battery Company CALB cells, the Sinopolys, which still appear to be more rumor than cell, and the Winston or Thunder Sky cells that we're using in the Escalade. At about 3.5 or 3.55 volts, this turns up rather sharply, and it climbs thereafter. You can sit there and watch the meter ticking. And from 3.65 or 3.7 volts on up, it's actually whirring, and you have to move fast to stop it. So one of the techniques we use when charging, as we start up this curve, we undercharge the cells a little bit. What we noticed very early in the game was that the manufacturer, Thunder Sky, used to say 4.2 volts to charge the cells to. Well, the difference between 3.6 or 3.7 volts and 4.2 volts was maybe an amp hour, not even, on a 160 amp hour cell. Now, why are we doing this? So we started charging the Thunder Skies to 3.65 volts. The CALBs have a much flatter curve, and they advised to charge to 3.6 volts. And so we started charging them to 3.5. And we're giving up very little, but we're protecting our cells, which do not like to be overcharged and do not like to be over-discharged. That's the two ways to mess up these cells. We have exactly the same situation on the other end as you're discharging from 50%. It discharges very slowly from about 3.2 volts down to about 3.1. And then it starts to accelerate a little bit, and at about 3.00 volts, we have this knee where we're turning and going for the floor. And below about 2.75 volts, it's actually ticking off. You can watch the meter. It's like a gas pump going as current goes out of the cells, even at fairly low current levels. And so this is a depiction of voltage over the entire state of charge of the battery. A lot of the BMS guys recognize that the batteries need to be somewhat balanced. They need to be roughly in the same state of charge at any one point. And so they very cunningly devised a methodology to, at the time, as we start up the curve, when an individual cell would hit a voltage, say 3.65 or 3.8 volts or 4.1 volts, and they do it at various levels, some of them right up at 4.2, they kick in a shunt. And that is a power dissipating resistor across the cell. And it actually kind of shorts around the cell and reroutes some of the energy bypassing the cell. And that'll hold the cell at this 4.1 volts or whatever and pass the energy on to the next cells in the row. And as each cell gradually hits that point and begins to shunt, they wind up shunting, anywhere from 100 milliamps to, I've seen them at 5 amps. They've lit up this whole board full of resistors that are giving off heat and basically creating a fire hazard. And so then all their cells are matched in state of charge at the top of the charge curve. And that's well and good. They're balanced. But they're balanced at the top of the charge curve. As I said, the cells vary in their capacity. Your pack cannot get any more energy out of the entire pack than it can from the very least cell. That's a maxim. There's nothing we can do about that. If you exceed the capacity of any of the cells, you destroy them. And so you can't get any more energy out than you can of your least powerful cell. And so by lining them up at the top and balancing them very carefully there, they take the random distribution of disparity in capacity of the cells and concentrate it at the bottom end of the charge curve. Now, here's a problem. As we go along, these cells are all traveling at the same rate of discharge. However many amps you take out at any particular time, all cells pass that same amount of current. So the cells with the lower capacity are going to be out ahead on the curve. And one of them is going to go over this, I call it the cliff, before the rest. And as it does, its voltage is going to start to rapidly decline based on a function of the amount of current that comes out of it. The amount of current you get out of your pack is, of course, a function of all your cells. And so these up on the top side, on the nice flat part, are still pumping out current very well. But the one that's short is diving like a stone, having gone over the cliff. And we visualize this by saying that the stronger cells are driving the weaker cells towards 0 volts. And they, in fact, do drive them to the point that they can reach 0 volts and actually reverse the cell. If you discharge any of these cells below about 2 volts, you diminish the capacity, you harm the cell and diminish the capacity of the cell by the act of doing so. You do not want any of these cells ever to be below 2 volts. If, however, you do that, the cell will still operate. It simply has lost a few percentage of its total capacity. If you drive it through 0 volts into reversal, I've never gotten one back. They never take a charge again. You can put a charger on them. They'll count up from about 0.6 volts, maybe up to 1 volt, sometimes up to 1.1 or 1.2, and then they'll actually reverse and start climbing back down. And the cell heats. And as soon as you pull off the charger, it dives to 0. I've never been able to retrieve one that went into reversal. We do not top balance our cells. We actually bleed all our cells down to where we're on this vertical wall of the charge curve. And we try to balance the cells there at some voltage. I like 2.75 volts. And I like that because it's well past the knee, which typically occurs at 3 or 2.95 volts. And that gets all my cells lined up at 2.75 volts. When we charge them, since we've lined them up at the bottom, as we charge the cells and they start up, they go off this knee very differently because we have concentrated the random differences in capacity at the top end. And so some of them are going to start up that curve before the others. So as they start to charge, we have exactly the same thing happens. Our lowest capacity cells will start up the curve much sooner than the cells that have a higher capacity. And so they start up, and we have concentrated our differences on the charge side. But there are some differences. In charging, we have a very set automated point where we discontinue. It's not about where we're driving to or whether we have to take somebody to a hospital and go past the level of charge that we thought we would. It's established in an automated fashion by our charger. And so it's going to quit at the same point every time. The other aspect of this is we're charging at 15 amps or 20 amps or 25 amps. In the act of discharging, we're trying to gauge where we are in our fuel tank. And some emergency might come up or something, and we have to go a little bit further than we did. But when we press the accelerator, we might be discharging at 1,000 amps or 500 amps or 200 amps. And those are very different regimes in time. Things happen in 10 or 15 seconds at this end. At this end, they happen in a half a second or a second and a half. And so suddenly you lose a cell and your car quits. That's not a good thing. And so we've learned to balance the cells at the bottom, and an interesting thing happens. As they all go over the cliff together, because they're balanced down here at 2.75 volts, as they all go over the cliff together, none of them can really gang up on the weak ones. And in fact, the pack as a whole, its ability to generate current deteriorates very rapidly. And so we've actually, on our original Speedster, driven it until it rolled to a stop with a very carefully bottom balanced pack, let it set for 10 minutes, drove the car another 2 blocks where it rolled to a stop and would not move, would not turn the wheel again. And we turned it off and let it set about 10 minutes and turned it on and drove the final 2 blocks to the shop and rolled into the parking lot and pushed in by hand through the door the car. After that, I just put a 120 on it so it would charge rather slowly and charged it back to full charge. We drove the car another 2 or 3 months and tore it down to do a rebuild with CALB 180s, larger cells, and more of them for a 192 volt pack that you see in Speedster Redux now. We took those batteries out and scattered them around on the concrete floor, kicked them and stacked things on them for about 2 or 3 months, and then put them in another car, and they've been driving for 6 months in those. We didn't harm the cells apparently at all. And so that has kind of proven to my satisfaction that bottom balancing prevents cell death. And so we've been bottom balancing since then. Dr. Dennis Dorfel said a very interesting thing at EVCon 2012. He said, but Jack, the bottom balancing is not very convenient. And I admit he's correct. It's not as convenient as top balancing. But in all of this, and I do truly love these batteries. If you could love an inanimate object, these have enabled us to cross a threshold of viability and make magnetic drive work for an automobile in a way that it simply never did before. And I have asked these cells to do many things, and they've done them faithfully. I think they return the affection. Everything I've ever asked them to do, including die, and including spew forth gases and fluids, and literally give their lives for a mere test, they have done at my bidding. So I have to assume that they have some affection for me as well. That said, not a single one of them has ever really inquired as to what I found convenient or expressed any concern about how my day was going at all. And I'm embarrassed to report that I'm equally callous whenever I'm driving the cells and driving down the road, putting 1,000 amps into the motor. I've really not inquired about whether they found it convenient or not. I just wanted them to make the car go. So convenience is not really a big deal. The other disconnect is that top balancers believe that the cells need balancing every time you charge, and that they drift. This is a leftover remnant of lead-acid batteries. Lead-acid batteries self-discharge if you don't have anything hooked up to them. And they do so at different rates. And so just left to their own devices sitting on the floor, they'll discharge to different levels of state of charge. The shuttle mechanism that causes that is not available in these cells. It does not exist. They do not have a self-discharge mechanism in the way that you think of it. Now, there have been a lot of press recently about the self-discharge of the Tesla motor car, and more recently, even the self-discharge of the Leaf. This has nothing to do with the cells having a self-discharge. We've tested cells 2.5 years later, and they're at the same voltage they were at when manufactured. The self-discharge concept is a little misapplied with regard to these cells. What's happening with those cars is that they have little DC to DC converters in them that make 12 volts, and they run the clock and the stereo and the GPS speedometer and the little circuit that does the J1772. I call them parasitic loads. They're simply things that have to be left on in order for you to be able to start a car. And indeed, if we park a car around here for any length of time, on every car we have a maintenance switch that we can turn off the pack, disconnect the pack from everything. And at that point, nothing in the car works. The DC to DC converter doesn't work. And that arrests any self-discharge of the car. The batteries themselves do not self-discharge. And there is no such drift. We have bottom balanced packs and revisited them a year later, and they're no different than they were. In fact, on the Escalade, I've actually made a list of exactly what the voltages were when I got done doing the bottom balancing of that pack. And we'll look again in a year, but I already know, I've done this enough, of what I'll find. They'll be within a few hundredths of a volt of where they were when I did it a year before. They do not drift. You don't have to bottom balance ever again until the cells get old and one of them simply dies on you from old age. And we've not had any do that yet. They last many years. And so as a practical matter, we don't have to do that. But when we do a new build, we've taken to doing the bottom balancing. Initially, we just did it when we were marrying in new cells. But as we grew more familiar with it and more familiar with the problem, we've got to where when we build the pack, we just bottom balance the thing from the beginning. It takes sometimes days to do, but we'll do them a little bit at a time till we have them all at about the same voltage, and then charge them all as a pack, and it's good from there to go. What Steve was talking about was a device I cobbled together in an hour one afternoon from stuff I had laying around. It is not a model to follow, and I'm going to tell you why. What this is primarily is a resistor, a 0.1 ohm resistor of 250 watts. It's from Vishay, I think. I got it from DigiKey for $55, I think. Dale Friedrichsen recently built one, and the best price he could do on this was $80 just for the resistor. So a precision resistor of that size and power handling capability is somewhat expensive. If we take a 3.3 volt cell and divide it by 0.1 ohms, we get 33 amps. And 33 amps at 3.3 volts is about 100 watts. And so a 250 watt resistor is well able to handle that. And I've actually got it mounted on a piece of aluminum honeycomb to heat sink it further. The meter, this little digital voltmeter with the relay on it, requires 12 volts to operate. And I have a contactor here that also requires 12 volts to operate. I route the 12 volts through the meter relay to the contactor. And the contactor simply connects one leg of the resistor to one of the little clamps I have here. I have two little clamps that go to the voltage sense inputs of the meter. And these are just on long, thin wires. In this way, I can measure the voltage without having the drop of the current through the cable. And so it's a more accurate voltage measurement. And so when the voltage decreases to a certain value, when I hook this up, if I'm above the value, the contactor closes and the two cables are connected to the resistor and bleed off current out of the cell. As the cell voltage drops, when it reaches a certain point, and I can enter that point, 2.6 volts or 2.5 or whatever I want, it will disconnect it. And then when it does, the battery will bounce back up. It'll start coming back up in voltage when you remove the load. And if it gets back to the upper threshold, it will close the contactor again and bleed it back down to the same lower voltage. And so it'll sit there and hunt maybe a couple of cycles until the battery comes to rest. And you can quickly set this up after doing it a couple of times to values. I typically use 2.65 and 2.75 to where it's going to come in after it rests for a while at about 2.75 volts. Here's the problem with this device. Here's the voltmeter. It's 50 or 60 bucks. Here's a little 12 volt power supply. I can get them on eBay for 20 or 18 or 20 bucks. Here's a resistor. My cost was 55. Here's a contactor. It'll list for 130 bucks. I get them on eBay for 55 maybe. So here's 110, 130, 180, 190 bucks, and I have to assemble it. And some wires and some clips. It's $200 in parts, and really quite manual. Yes, I could post the parts list, and I will, Steve, if you insist, but it's a dead end. It's too expensive, the components, and it doesn't do enough. All it does is do a discharge of the cell to a specific value. If you put this on every cell in your pack serially, then when you get to the end, you will have bottom balanced your pack. That's true. This is another device. This is a CellPro PowerLab 8, 1344 watts. It's manufactured or sold by Revo Electrics, REVOLECTRIX.com. It's $197. It's made really to do radio control helicopter batteries, LiPo batteries. But those devices, which first appeared a year or two ago, have grown dramatically in power and capability. this particular one, CellPro Power Lab 8, will charge at up to 40 volts a cell or cells. You typically, again, deal with one cell at a time. And better, it will discharge at up to that rate. And better yet, if you do it from a battery, it will actually take the energy that you bleed off the cell and store it in the battery. They call it regen. And so the power isn't wasted. Better yet, it has a little port on the bottom and a device that they sell that gives you a USB output that you can connect to a Windows PC. And in fact, they have some software you can run to do all this on a PC, make graphs. In theory, you could run LabVIEW on a PC off of this device. And so it has a huge number of features, but it has 24 presets in it. You select a preset, press the increment and decrement keys simultaneously, and you can change all the values in that. And so you can set your discharge current, your charge current, the charge CCCV switch voltage, and it will charge to that voltage and hold it there until the current diminishes to a low value and then disconnect. You can discharge the same way to any voltage you want, and when it hits that, it quits discharging. And it counts amp hours for you when it does so. So this is a whole test system for cells, and it will do the same bottom balancing function, charging and discharging, and even work with your laptop computer to develop charts and graphs. You could do cycle testing. It will do a charge or recharge round trip cycle. It will act simply as a monitor and monitor voltage and current, or it will do just charge or just discharge. And it's fairly easy to set up using 4 keys and a little 2-line display, and the whole thing is $197. Well, that's what this costs. And this does a whole lot more, and you can simply order it. It's got a couple of cables to hook power in, and then it has both a port to connect to any of these little boards where you can do 8 little cells at a time or 16 little cells at a time in parallel. We're not going to do any of that, but it also has some banana jacks where you can, yeah, that's what this port's for. The PC port, can't remember where it was. This one here similar, little PC port. Yeah, this is a balance port here. I don't remember where they had the, oh, here it is, this little 3-pin here. It's a little adapter that slides in there, hooks up to your PC. So we hooked this in with these banana jacks into the bottom, and that gives me 2 little clips, which are actually quite good at holding A123 cell tabs. If you recall, we had a cell short, and if you recall further, I just said a little while ago, if you take a battery down below 2 volts, you do diminish its capacity. These are the 2 cells that were there with the short, and I'm pleased to report that they've come back and are fully functional. But we want to test them to see what their capacity is. So it comes up Power Lab 8 version 2, firmware version 3.25. I press enter. It says battery, a power source. You have the choice of battery or a power supply. Back in the lab, I use the power supply, not these batteries. I'm doing this to demonstrate that they will do regen and so forth, and do it out here away from the mess that my battery labs become. The preset I have selected is A123, 2300 milliamp cells. That's a little cylindrical cell for radio control helicopters, but it uses the same voltages as these 20 amp hour power cells, and I've gone in and modified the high power settings to do 20 amps charge, a 20 amp discharge, a discharge voltage at 2.5 volts, and a charge voltage which was already set at 3.65. I could have used any of the presets and set them to anything I wanted, but the high power, there's apparently different ranges of power. This is meant to be a these things started out doing milliamps, and they've gotten up. This one will do 40 amps now. It says parallel packs. I'm going to answer no. We're not going to do that. Set charge rate. I've got it at 20 amps. Set discharge rate. I'll take the 20 amps. Start charge only. Use banana jacks. Yes, that's what I want to do instead of the little parallel port thing. And I get a yes or a no. I'm going to set it to yes for banana jack. It says it's checking the pack. It's A123, and press enter to confirm. And I press enter. Now, well, I'm going to have to go through all that again because I timed out while I was explaining it. Checking pack, press enter to confirm. And charging is set, 20 amps to 3.650 volts. Here's the little display you see. Brain, can you give us a little close-up of this thing? Here's your 4 buttons, increase and decrease and enter or go back. That's pretty much how you control it. And you have a little 2-line LED display. So very basic. By the way, it can discharge without regen into the battery pack using an internal shunt at up to 100 watts. Well, 100 watts divided by 3.3 volts is, again, about 33 amps. So this thing could discharge 30 amps using none of this battery here. You don't have to use a battery. And so it's charging. Now I can use the increase and decrease to set different things or watch different things. It says it calculates internal resistance. I haven't caught it in the act of actually doing that. Supply battery, that's this. We're drawing 2.7 amps out of it at 26.2 volts. The capacity, right now it says 365 milliamp hours in, but that is going to clock up and give us our total amp hours that we can store in this questionable A123 cell. The elapsed time. The current voltage is 3.132 volts. The pack equals 3.143 volts. Fuel level equals 4%, which, okay. Start fuel is 0%. Start cell voltage was 2.83 volts when we started. And the next one is high power, charging at 20 amps. And so I'll cycle this to my capacity, which is the amount of amp hours in that I've got. And you can watch this cycle. Brian, kind of zoom in on that. Does that appear on screen? Good. And we'll be back in a few to see what it comes out to. When last we spoke, I had hooked up the power lab and set it on charge. It terminates quite automatically, and my capacity display, if I can get a little close up here, shows 16.29 amp hours. Again, I can cycle through the various values and review. So for 4 buttons and a 2-line display, it's really quite usable. The only disadvantage I see to this device is you do need a power supply of 10 to 36 volts DC. You don't have to use 2 monster batteries unless you want to use the regen capability on it. A little 12 volt, 10 amp supply would probably let you do 40 volts, 35 or 40 amps charge. And even without the regen, this has a 100 watt discharge in it, which is over 30 amps on a single cell. With regards to the cells, if you'll recall, these 2 cells were in a pack that averaged about 18.6 amp hours per cell for 55.6 or 8 amp hours total, as I recall. 1 cell shorted, and it was good. It tested good. We charged it, we discharged it, we zero balanced it, charged it and discharged it again, and then somehow overnight one of our 3 cell units bled down to 0 volts. We took it apart. 1 cell was 0, the other 2 read 0.6 and came right back up within a few minutes to about 0.9 volts. That's alarming. It should be some loss of capacity. In one case, yes, in one case, maybe no, or not so much. We have charged and discharged these several times. This one, we just got the reading 16.29 amp hours. This one, 18.06. After being drug into the bushes by the shorted cell, which of course has never come back. 18.06 amp hour. If we take our 18.6 amp hour average, suffered a capacity loss of 2.9%. The 16.29, had it been the same 18.6 average, would have suffered a 12.4% loss. And both of these are pretty much below most of what we're seeing. Almost everything is 18.5 amp hours now, and most of our cells have been up over 19. So I think they have been damaged, 10 or 12%, perhaps, by being taken down to that low voltage, but they're still fully functional cells. I would not use them in a pack at this point because they're too small. And so that's it. Sure, Steve, we'll post the parts list if you insist. We've had a number of requests for us to sell this in the online store on our EVTV website. I do not see the point. Number one, I would have to assemble them. And number two, this is a big clunky device that does one thing. Here, for the same amount of money, you can get a device that's truly a test set for single cells. It will do the bottom balance trick. It'll also charge them, and it'll round trip that, where it does a charge and a discharge. If you get the optional adapter, I think it's called an FUIM3 on their website, it'll let you plug into a PC and automate this even further. And they have some software that goes with that, so you can get into cycle testing and all manner of things. So this is, again, a very cunning device, and courtesy of the radio-controlled helicopter community. They're getting up into some powers, apparently, as this does up to 40 amperes. And so I think it's a great device. We've got 4 or 5 back there I've been playing with. This seems to be the best of the lot. It's the Cell Pro Power Lab 8 from www.revoelectrics, revolectrix.com, and about $197 without the adapter. They have different configurations of this. that go up to, oh, I don't know, $280 or stuff. You're mainly buying cables and adapters, and apparently there's an endless series of those for radio control helicopters. For your purposes, they provide a couple of banana jacks. I made these wires with the clips on them to plug into there. It comes with the jacks to connect to the battery. So I think that's a much more capable device, more readily available, and not dependent on my clunky design here for a discharge device. And so it comes with quite an extensive manual, actually, some 70, 80 pages. I can't read it all, but the little bit I have gone through, which made it very usable, was reasonably well written, if excruciatingly boring. So that's it for the bottom balancing and the equipment that you might want to use to actually accomplish that. I do, frankly, even without this device, keep around one of these resistors with a couple of clips, and a lot of times, if it's just trim up a cell or two, I'll use that, a voltmeter, and it still works. But this is a much more automated way to use it. You can literally plug it in and walk away and come back an hour later and it's all done. And so that's, and you don't have to worry about ruining a cell. I can't tell you how many times I've gotten into a conversation with the daughter or the wife and forgotten about the battery, and I have lost cells that way. So that's it for bottom balancing.
That's pretty cool. I hadn't seen that product, and bottom balancing, hey, that's important. We like it.
These guys are easy to wow. I'm a little cobbled together pile of junk. They went, okay, here, let me show you a little device.
Let me show you something someone actually put together.
And so that Revo Electrics is pretty cool.
Yeah, those radio control guys, I mean, we've actually learned a lot from them.
I've been following them for years. I've gotten sucked into some things. I spent a lot of money on a CBA tube that just basically blew up in my face. It did. Every time.
Yeah, it did. It's kind of dangerous.
A whole bunch of fuses and MOSFETs and shit every time you put it under any power. It was a radio control guy that ramped it up for demand, but he didn't have any reason to do that kind of current.
That kind of current,
That kind of power.
Yeah.
So he built the device, an amplifier, to do a lot higher thing, and
it just kept blowing.
Yeah. So and he had some kind of weird thing with the software that was tied into the actual computer I installed it in, and he had to give me another code if I put it on another computer. If I said, look, we can deal with professional products. We can't deal with this kid stuff.
The professional ones are bad enough.
You taking care of the neighbor kid and his Visual Basic is not my problem.
That's right. Just get it done. We have enough problems with Microsoft.
He actually was eat up with anti-piracy. He was afraid somebody. I said, "Guy, you got a software program that only does one thing.
Yeah, what
and it only does one thing with your hardware. Pirate it and do what with it?
What are they going to do? Like have it all? They're going to spread it all over the world. It's going to go viral on some site.
You have to have your hardware to use
I know,
it all.
That's right. Let them get the software.
This Revo Electrics device that we just talked about, they've gone the other way, equally as irritating. There's no software in the box. You have to go to their website, and you don't download the software. You have to have Windows Net 2.0, and it installs over the internet on your device. That's a little too far for my taste. So that's kind of what we've got going. We've been playing with battery cells. I'm still working on Platinum
Still
series.
playing, the Platinum's kind of getting a third layer ready.
And so that, we've got layer 3 in the lab assembled. It's a lot of work to put this together.
I know.
There's just so many holes you have to drill. It took me a day to do the hardware for this layer, and it's the third one I've done. And I knew how to do it this time.
I went this was about as fast as it would go.
And it still took a day just to run off the hardware to make this layer on this polycarbonate, and then another day to assemble it and get it up in the lab and start bottom balancing it. And so it's These A123 cells, the problem is they're the solution for the wrong guys.
I know.
The
They
guys
really
that
do work.
want
I
to
know.
do lead and
have
would
an
like to go
inexpensive
lithium
pack.
and have an inexpensive pack. I'm not convinced you can actually make a module, guys. This takes a certain level of skill. I can build the car easier than the module.
Yeah, the module's been a real pain. Yeah.
Now, I've always said that the battery boxes are 50% of a car build, but this is in.
to get like 80% of it.
You know, I could have done 2 Speedsters in the time I've got in.
You could have slapped some batteries in a Speedster.
Yeah, I mean, order up some aluminum boxes, bolt them in, throw the batteries in.
Yeah, motor, controller,
charger,
DC converter down the road.
Yeah, I mean, I could have a car on the road
we
in
could
the
have.
time I've put into this pack.
Yeah.
But the prices are dropping. I don't know what the future of the cells is. Well, I do know what the future of the cells is. They're going to be less expensive and they're going to be quite available, whatever happens to A123.
Right, there's obviously people out there manufacturing them.
There's people in Korea making them.
Yeah, there's people making
There's
this
plants in China starting to make them, and there's no demand for them here.
No. No.
So if they can find somebody that would care, they're going to keep the lines open.
Mm-hmm. Yeah, they got the investments. Yeah. Yep.
And clearly at this point, the price has eroded to the point that they're actually pretty much value. This module I'm getting, which is probably used, but it's assembled as a module. I got to look at one.
Yeah, we at least need to see one. Yeah.
But it works out to $10 a cell.
See, that's pretty good, including the module.
Yeah.
Wow. Yeah, that's worth taking a look at anyway.
Well, I had to order one.
Yeah, that's worth looking at. Yeah.
And so the irony is that A123 may go out of business and leave an open source battery box.
I know, that's out there.
With their technology spread among a couple of different continents.
Machines out there to make them, everything.
Assembly lines going away and no company to receive the cells. I mean, that's the kind of times we live in, and probably at this point, I would say the most likely outcome. I do not think that anybody, they recently signed up Tata Motors in India, but I'm having a hard time picturing any OEMs or anyone with any serious plans for producing electric cars, considering this company's batteries.
Right now, yeah. It's
unless they can demonstrate another sudden $1 billion infusion of investment.
Yeah. And the government isn't going to step in this
time.
I
don't think well, they did extend their grant period.
Oh, really?
Yeah. Now, when I say they have a grant, I'm from the government and I'm here to help. Do you all understand what happened? You can't imagine the number of people that suggest I apply for a government
grant. Oh, God.
Like,
and they may never give you any money if you have the grant.
That would be like ordering poison ivy from the Sears and Roebuck catalog.
Yeah, that's right. That's
I mean,
exactly
in my world, this is unspeakably a horror.
Right. Yeah, no, it's not a good thing.
So let me tell you about government grants. They have a $249 million grant. Mm-hmm. The government didn't send them a check and they spent it.
No, they don't send you a check, no.
It's sort of a matching funds grant.
Oh.
If you put in $10, we'll put in $10.
Okay.
And you have 2 years to put in your part.
To use it, okay.
And we'll put in our part.
Okay.
And of course, you need a full-time staff of 30 just to
manage
us
that. That's right. Yeah, legal
while
departments.
You're doing it.
Yeah.
Because we want to know
compliance
everything that's going on while you're doing it. And we may have a few suggestions for you along the way.
That's right. We're very helpful, you know.
Of how you ought to be doing it, since we're experts at being the government.
Yeah, that's right. We're government experts.
They've only used half the grant.
Okay. Okay.
And now they don't really have the money
to come up with get the rest of the money.
Yeah. The matching part has to kind of be up front.
Okay.
You spend it, and then they
reimburse you.
Yeah.
Give me your receipts.
Yeah, that's kind of how that goes.
Oh,
and so, but that has been extended out to 2014. So that's the only light in a very dark tunnel for this company.
Yeah, but they would need to raise a lot of money to get that money.
How are they going to do that?
Who's going to do that? Yeah.
I know a guy in Russia. A couple bottles of vodka.
Couple bottles of vodka.
Couple of girls.
It's a party. That's right. And a little baby giraffe.
Right, and a little baby giraffe. And I think we can...
we can make a deal?
We can talk.
We can talk. That's right. Oy vey.
Oy vey.
Oh, man. Well, you know what they say. If you invite the circus of town, you can't get mad when the clowns get loose.
That's right. That's right. Your opinion on the smell of elephants is
that's right. The clowns,
really germane at that point.
That's right. The clowns are loose, man.
That's right. Creepy clown. Animal.
That's it.
Balloon animals.
Balloon animals for the kiddies.
Yeah, so, I think I know a Russian.
That's right. There's probably somebody
Maybe
out
we'll
there.
hook him up with David.
That's right. There's got somebody out there, ex-arm dealer or something, huh?
Oh, my goodness. What a world, as the Wicked Witch said.
That's right. What a world.
And so there you have it. David, I feel for you at this part.
Yeah.
Come on down. I'll bring the whiskey.
Yeah, that's right.
We'll talk about the good old days.
That's right. The halcyon days of battery industry.
Halcyon days of battery industry. You come to EVCon, we'll break out a bottle of whiskey.
That's right.
Well, let me tell you about daughters. If you think battery,
I think
battery
is bad.
How many daughters you got? So there you have it. I don't really have anything additional this week. We have no photojournalists out there assisting me.
No, we didn't get anything in this week. No.
Didn't get anything over the transom.
No.
And, so typically we film on Friday afternoon and Friday evening. All hell breaks loose with stuff that we should have talked about.
That's right. Yeah, that's right. As we're on camera, then the industry knows now. It's kind of like the stock market.
That's
you
right. They
make your announcements after after the close.
We're shooting.
That's right. I think they got us nailed.
So, yeah, A123 is in the bucket on the stock market, but. The market's picking up. Car sales are picking up. Mm-hmm. The gasoline is about $3.92 a gallon for regular now, nationwide.
It's getting up there. Yeah.
And it's changed the nature of the car sales. The public does respond to this, and our national fleet average by month, if you take the mix of cars that actually sold,
that are sold, okay,
and what their mile per gallon is, you can average all that, and it's held steady at 21 and a half miles per gallon for 5 years.
Yeah, for a long time. Yeah.
It's 24.
Okay, that means people are responding with buying some fuel-efficient vehicles.
The Prius has been well received.
Yeah.
And I think it started to hurt at the pump. My theory is it's not so much the price as the duration.
Yeah.
If you want to have $4 gasoline for 40 days and 40 nights, we can all declare Lent and stay home.
That's right. Yeah, we can all do something.
But if you're going to do it for 6 months, guys, the family budget doesn't.
Right, with an unknown out there, there's no telling how long it's going to be.
You don't know.
Yeah, it's just a big unknown.
It's begun to swing. All quiet in the Straits of Hormuz.
Yeah.
The presidential election has turned into comic relief.
It's a nightmare.
In the battle over who's bending over the most women.
Yeah,
it's just gotten to be ridiculous. And we have the choice between Barack Obama and Obama Barack. Mitt and
that's really it.
I can't throw a dead cat between them and get it to land on the ground.
That's right. It's just like it's getting squished in between.
Right. This is a democracy. It's supposed to be about having options and choices and different directions to go. This is not so partisan. It's like all these guys are wearing the same clothes.
Yeah, no, there's not a lot of
I
difference.
can't
this
throw a
time
dead
around.
cat between them and get it to land on the ground. And so I'm fearful that Ron Paul is all that can save us now. This guy looks more like a prophet all the time.
Oh, Ron Paul.
If
Yeah,
you go back
he
10
said a
years,
lot
what he
of
said
stuff. Yep.
And what's happened?
Yeah, yeah.
Sentient adults would do well to listen.
Yeah.
He sounds a little wacky. I sound a little wacky.
We got Ron Stradamus out there.
That's right. This guy's, wow.
Yeah, no, he a lot of stuff he said.
He's scaring me.
Yeah, a lot of stuff he said. That's why he doesn't get the traction. It's just, it sounds crazy, but a lot of it's been true. What do you do?
What do you do?
Well, you can do what economists do. You just sit out and don't vote. You know, it's just too many people anyway. It really doesn't matter. Well, I don't know.
Well, meanwhile, we'll see you back here next week with another episode of A123 TV.
That's right, A123 TV. Until then.
Stay with us.